Catus, Maximus here. This time a review of the Vevor 18-inch. They're calling it the 12 amp or the 1440 watt, 2 horsepower from the wall. This is their large electric rototiller. There's actually, these things are more popular than I imagined. Not just Vevors, but there's a lot on Amazon. A lot of them have a lot of reviews. So Vevor saw that as jumping into the game. Not as powerful as some of them. There are some pretty respectable ones. This one isn't so bad, but you'll see later in the video I tear this all the way down. I don't remove the worm gear, but I get into the gearbox. Points to this, it is an oil-filled gearbox, and you use like skill saw warm drive oil with steel gears. They ought to last a long time, but there's a lot of upgrades and like fasteners. The motor actually has just shielded bearings, not rubber sealed, and they'll wear out quickly. Plus there is like a backlash issue with the motor where it can kind of shift around. For the price of this, I mean, it's value engineering. I think for around the $150 mark, you can get it cheaper when they go on sale. It's not bad. It does have the upgraded stem, which has gusseting. The smaller model does not have this extra rib on the front and back. I will mention that the wheels are like the flimsiest I've ever seen. A lot of the other electric tillers have a much better setup for holding the wheels. It was just this flimsy thing, and it ends up bolting to the gusset on the back, and I just thought, you know, these wheels are so flimsy, they're not going to do anything anyway. It's not very heavy to carry, and all they're going to do is stress that. Put up a lot of sideways force on that rear gusset, which is taking a bunch of the loads of tilling. Oddly enough, no Vevor logo on the side, but it does have it on the top, and oddly it has this 960 to 1440 watts. And strangely enough, I think they're doing that. It doesn't have 2 speeds. It's just the no load watts and I guess the full out or continuous output watts. I guess that's just to help you judge the size of the extension cord. 2 horsepower in from the wall. It's probably delivering 1.5 to 1 3/4, you know, at the tines. Oddly, it says Vevor on the back, so you get to see Vevor when you're running it, but there's just an orange box on the front. It's odd. By default, the tines are offset rearward, and they are directional. What we have is we have a chamfer on the leading edge, so that it catches a little bit less. Interestingly enough, if you don't like the tines being offset backwards, the way this is set up, it's like, you know, these rototillers, there's a variety of units. Various manufacturers use different parts that are similar. God, that was a terrible way of saying that. Anyway, this is bolted to a little steel adapter plate, and you can pull out the bolts and actually flip this around. You would actually need to take the tines and then swap left to right so that they would be still pointing in the proper direction. But if you want, you can swing that or flip that around. Technically, you could even put it sideways if you wanted to, but you can flip it around and offset the tines to the front, and that might help prevent a little bit less dirt from getting kicked up on you. Other than that, I'll mention later in the video, it does use what appears to be a pretty standard 19mm or 3/4 inch axle. It only sticks out so far, so you can, if you wanted to, get this and then put on narrower tines and maybe cut off the extra material here, and it could be a more narrow 14-inch unit, just with more power and torque. And even though this only has a 1400 watt motor, it moves pretty slow. Some of the bigger ones that have like 1800 watt motors, I've been watching some of the videos, they seem to use that extra power to spin the tines faster. Where here, it's just a little bit less power. Oftentimes, since it's a plug-in, you're going to have this on long extension cords, more than likely like 50 foot or even 100 feet. So there may be a trade-off there. The 1800 watt ones are powerful, but if you need to use it on a 100 foot extension cord, it'd have to be a 10 gauge cord, which are $120. A 100 foot 10 gauge cord would be almost as expensive as this tiller. So you can use a 12 gauge cord with the 1400 watt motor and, you know, get away with that. So there's definitely a balance to these. Anyway, we'll get inside it. give it a little bit of a run. It seems to actually sound a little better than when I started. I even added a little bit of skill saw oil to the gearbox. Just figured, being a cheap product, they probably didn't put as much oil as they should have. What? Doesn't sound that bad. Doesn't actually spin that fast. There's quite a gear reduction. That really is a tiny worm gear against a large spur gear. And one final upgrade. These little handles here, they just cinch down on this curved surface. It doesn't offer very much friction. They really like to get loose easily. This is an optimal place to actually have a washer, because in the washer stays flatter and adds more friction, and the handles will not get quite as loose quite so quickly. Not to say that they won't, but it is something that they should have done. And these are nice big washers, so the whole plastic surface actually sits on them. So a lot of work. I mean, this thing really would have worked just fine. It's just now it's a much more, I mean, it's just more robust. I guess that's what I did would be the difference of this. You know, and the prices vary. The smaller one's only like 80 bucks. This was 150 at the time I reviewed it, but they often have pretty steep discounts. But the stuff I did is the difference, you know, of another 30 to 50 bucks on the price of the product. Everything else being the same, just making sure like the motor had better bearings and was properly tensioned, and just upgraded fasteners and washers. Pulling those little foams out of those exhaust vents, there's a lot more air going through there, so it's not going to overheat as quickly. It is nice that it does have overheat protection. And even though the cheaper one is a lot cheaper, the big difference on this 18-inch is that we have these gussets on the bottom. You can see a lot better. Gussets here, which is where the wheels mount, and then this big front gusset. I've seen a lot of not a lot, but I found a few photos and forums where just the smaller ones that just have a aluminum tube end up cracking somewhere. Just they get so beat up. So the gusseting is nice. So at first I was going to try to remove this cap to see if this had oil in it or if it was just greased, but this cap was put on really tight, and actually since it was new, I could see the markings that it was standard threads, clockwise to tighten, counterclockwise to loosen. Sometimes these things are backwards, but it's really shallow. It's a 10 millimeter, but it is really loose, and the bit just wants to strip out the hull. So the only way is really with a impact, but I think it may be easier just to tilt it on its side and remove these fasteners, so I'll try that. Also, I wanted to point out when I guess when I pull off this side, but these are like some dust caps, little felt seals, and then there's actual shaft seals, and then the bearings. But these little convoluted kind of cup seals just don't stay very tight in there, so I found a few washers. It's a 19 millimeter 3/4 inch shaft, so you can pretty much just find any tine that will fit a 3/4 inch or 19 millimeter shaft. But these things are going to want to fall out, and it's going to expose more dirt to the actual seals, so I put in some washers just to take up some slack. These things do shift back and forth a little bit here. I guess this setup would be relatively true on a lot of rototillers, but they should have had like a snap ring here, because this held like a tiny amount of friction. I guess you could bend or warp this just a tiny bit to help it stay in there, but that's a shield. And then what we have is a little felt seal under it. Which, by the way, is not pre-oiled. It's just a dry felt seal. And then those are actual shaft seals, so that's what makes me think that it's oil-filled gearbox. They are using nut and bolts, so at least that's something. If these strip out, at least it's easy to replace. The nut just has a little recess. And at least they did this. It's all steel gears, steel worm drive, which is definitely pretty strong, but oil-filled. There's actually a little O-ring right on the bottom edge of this. So it's pretty easy to take apart, and if it leaks out of there, it's easy to replace the O-ring. And the oil bath means that all the teeth are always getting fresh oil on them, and should really make a big difference in the lifespan versus many of these which use a bronze gear, which is pretty good, but this is a really kind of rough, a lot of forces in this gearbox, so I actually approve the all steel gears. And to digress a little bit, the theory is, in like worm drive skill saws and stuff, is that the big gear is bronze, where the worm gear is steel, and the idea is inside an oil bath they kind of seat against each other in such a way where they can, I guess in certain circumstances, outlast actual steel gears. But this is fine. It's nice to see that it's an oil bath, although it's a little bit dark. And as far as how much to fill it up, it looks like the oil is maybe to the bottom third of the gear. So down in this little gully here, I can just see, I don't know if you can see there, but there's enough oil in it where it's just coming up and starting to get onto the bottom of the gear. You don't want to put too much oil in a box like this, otherwise it needs a certain air volume for the oil to expand when it gets hot. So if you put too much in, then there's too much pressure and it blows out through the seals. And I'll mention it again, even if you get one of these and then put narrower tines, since the tines, this could be either a 10 inch, a 14 inch, or an 18 inch, depending on whether you have 1, 2, or 3 tines on the stack. So you can order this and make it more narrow, but the smaller capacity ones, it's just this cast aluminum stem. And on the bigger 18 inch model, these flanges here, these extra ribs support, are only on this bigger 18 inch model. And that's one of the reasons I would recommend it, is just because on the smaller model, there's a lot more risk of this stem here breaking, where this just has a bunch of extra ribbing and is just beefier and more robust. And my second bad, I thought that was going to be a ball bearing in there. No, it's just a steel sleeve, and because it's in an oil bath, they're just relying on that for the lubrication. Maybe for the cost and the durability and how long that steel sleeve will last, maybe that's the best option in an oil bath. But I would have thought maybe at least a roller needle bearing. Pull it apart, it's pretty easy, just 4 screws to pop the whole cover off. There's like these little foam filters, I guess, in the intakes. Excuse me, not the intakes, oddly enough, across the exhaust. I guess that's just to help, they're real simple filters, just to help prevent dirt particles from, I guess, getting in there. And pulls air through the vents from the motor housing down through the motor. It does have an overheat protection. That's a overheat thermal switch, so if it ever just shuts down on you, let it sit for a few minutes and it'll be this little thing here. Ball bearing, that is a 608, but it's not a rubber sealed, especially in something that's going to be working around the dust. I think I'm going to preemptively replace that with a rubber sealed ball bearing. That's one little disappointment. It does have really long brushes. They're like vacuum cleaner brushes, so at least it's designed to last quite a bit of time. I mean, if you ever get to a point of needing to replace the brushes, they're not hard, but once again, it'll be quite a while. And I do like that they added little vents here to really allow a lot of air to get past them. This is a pretty hot running motor. Decided to shred it. I'll actually get it back together. So this is the lower motor housing. Here's the fan, so it pulls air through here, then flings it out that way. I think I'm going to pull these little filters out of the exhaust vents, just because I think they'd eventually clog up and restrict airflow more than they would prevent anything from really getting into the fan, because the fan sucks in through the upper housing, is blowing out through here. Just a basic field winding, not even wrapped, but what are you going to say? It does have pretty thick wiring on it. Even though this is all like metrics, it's Chinese made. Oddly enough, these bolts that hold the motor together were exactly 1/4 inch. A 6mm socket would not fit on these, and a 7 was too loose. It's kind of strange. This is a high density motor. These are very thin bars. There's a lot of windings to get high magnetic field values. So this motor is going to run warm because it has a bit of a higher power density, gives a little bit more torque, but it's more expensive because they have to do all these extra windings. Just a little bit of balance grinding there and there, nowhere else. So surprisingly enough, got lucky and have a naturally perfectly balanced motor. 6,000 bearing there and a 608 here. I know I have a rubber sealed 608, so I'm going to swap that out, but I can't believe they didn't put in rubber sealed bearings. These are going to get dust in them pretty quickly. It was really something they should have done. I assume this tiller head is shared with some of the gas ones, so we have a steel spline shaft, and then we have, you know, it works, but it's a fairly crude aluminum casting, which is an adapter. The fan sits on the motor with two flats. That's what drives the fan, and then the adapter plugs into the fan like this. It's interesting, there's two parts. There's the motor to the fan to that aluminum adapter, and then an aluminum adapter to the steel splines. Quite the stack up there. And surprisingly enough, I don't think it's going to be this finger system to the fan. That's a lot of surface area. I think that will hold up. Even though this is a small motor shaft, I mean, it is wide. We're talking probably 50, 60 millimeters, a couple inches or more than 2 inches. Two flats, it's actually enough surface area where that ought to hold up. I think if anything eventually blows out, there is no clutch in this, so it's going to always deliver all it can. And all that power going through these splines here, these small diameter ones on this aluminum adapter, I assume that's exactly what's going to end up failing on this, just due to vibration and wear. Now, even though it's about a 1.5 horsepower motor, most of the gear reduction and load is being taken up by the worm drive down here. I mean, for the price, I'm sure it'll last more than long enough. Just would have been nice if this piece were steel, then you know it would have had extra long life. But that being said, it is direct drive, so you don't have the additional gearbox or belts. Many of these do have our double reduction and allows them to have a smaller head down here. But in this case, it's probably an okay trade-off. Well, this will bode well a little bit for the longevity from the steel shielded, which once again, working in a dust, being a rototiller, those bearings are actually going to have a short life. This ought to be better. I found a NSK 6000 rubber sealed, and then I had a new no-name 608 for the back, so at least it's a longevity upgrade for the motor. So I got the rubber sealed bearings on there nice and good. There they are, but I was noticing, well, I was taking it apart, a little bit of shifting, and indeed, you can see where this is at here. There's quite a bit of motion. There needs to be like a wave washer, which I do have, but that's also going to contribute to wear because it'll allow the motor to vibrate up and down, causing more brush wear. But that vibrating and sliding up and down will also wear out the nylon bores that the bearings are sitting in here. So that's also, I mean, that's an oversight. That really will, the way the motor could bounce around like that, I mean, it's a tiller. It's going to be jerking up and down with quite a bit of force repeatedly. Those hard bearings are just going to get loose until the motor wants to rattle around. Eventually, the armature will start contacting the inside of the field. And this is, you know, everything's, you got to make sure that this seat's all the way down, screws are torqued. I'm going to have to get a wave washer. I can't believe they didn't do that. The unshielded bearings and the fact that there isn't, that there's slack in there like that, it's unfortunate. These are the wave washers. They act like a linear spring, and so they come in various sizes. When they're real small, they're just curved. They're not actually wavy. So I'm just going to find one that seems appropriate. Some of these are a little bit thicker and have more tension. Some have a little less tension. Since this is not the most expensive tool, I think I'll find just a little bit lighter of a wave washer and see what I can't do. I don't have to choose either. I may have one that's appropriate for the back of the motor, and if I don't have one that's the right size, it can't be too small because it'll eat into the seal, and so it really, the outer diameter really needs to be pretty close to the bearing size. So I'll be able to use it in either the top or the bottom. Although I'm hoping to find one for the top. That way it forces the motor more, well, yeah, in the downward position. As I was reassembling this, I was taking notice of these kind of like plastic lag screws, but they don't have, they're like a socket head cap screw, but really more for wood, because they don't have particularly deep threads. And this is what, I mean, the leverage from the handle and all the forces from the tines levering this is all held together in the sandwich between the drive stem and the motor. I just thought, you know, it's going to get hot and expand and contract, and I know from plenty from power tools that screws like this in plastic under high torque situations where they're taking a lot of load and dynamics, and will end up working their way a little bit loose. I thought if I'm going through the effort of upgrading the motor, the sealed bearings, and I did get that little, I did find a, come on camera, here, jeez, I did get a little spring tensioning washer so the motor won't rattle. Figured I should go for the next step, and so I ended up finding, surprisingly enough, I guess M4mm diameter thread. It's about the same as these, so I can actually just thread those in, screw them in. They kind of cinch down just with the fine threads, and then I'm putting in one of these integrated washer nuts that's corrugated, so it really will stay tight. So it actually has pulling via the threads, even though they're not quite as deep as these plastic ones. There's like 3 times as many, and then I have a nut that's gonna hold it tight. I could only find grade 8.8 metric fasteners, but that would be good enough for this. So I figured if I'm doing all these other upgrades, these are the bolts that come through and hold on the main handle, so there's a big time stress point there. You're actually using the handle to flex on this top plate that then the stem and motor and everything is connected to. So it is flexing back and forth, and I thought, just versus the regular bolt head, the metal's going to want to deform there, so all I'm doing is upgrading, a little upgrade by actually putting a washer on there, so that helps kind of spread the load out a little bit more, and hopefully they'll stay tighter a little bit longer. 14mm and then 13mm nuts, so at least it's easy to work on. They just use a washer in here, and then the nut just kind of squishes down into it. And I think lastly, these were the bolts that just hold the top cover on. It's not a stress point, but I figured if I'm doing all this other stuff, I was noticing that the bolts that used to hold the stem and motor and everything together, these are exactly the same size or thread diameter. They're just a bit longer. I want to do it this way. They're actually quite a bit longer, and I have some of these larger washers, so even if stuff gets bashed, or maybe even if it gets dropped on this lid, it might hold on a little bit better. And these, the holes that accept the bolts go pretty darn deep. Let's go through all the mods. Reuse bolts that are longer and hold more securely for the main lid. Replace both the bearings 6000 and a 608 with rubber sealed bearings, as well as found a wave washer to pre-tension, because the motor would slide around, bounce around, which was unfortunate. Upgraded the fasteners. This tine is obviously for multiple units, so it's screwed into an adapter plate. This adapter plate upgraded the fasteners from just being these, that's where these came from, to full through bolts with corrugated or washer head nuts. They're forged with the washer in them, and then they have corrugation, so much more secure there. Put washers under the handle bolts here. Added some washers just so that will keep, they're not tight, but there's just enough to prevent these dust caps from wanting to slide out. And they just had really low grade, like grade 4 metric fasteners, really soft. I had these grade 8 shoulder bolts, which are smooth and a specific diameter, and they just have threads on the end. They happen to be machine threads, so I went ahead. They're a little bit too long, so I have double washers on each side, and then I use jam nuts mainly to protect the threads, but they won't ever come loose. Jam nuts are super reliable. And the soft bolts were threaded the whole way through, so as this wore, if you ever needed to replace these, or maybe one of the welds breaks and you're going to try to re-weld it, the way this would beat up that soft fastener and the threads just would have made that bolt, it could have made it pretty difficult to remove. Even if you got the nut off, it could have been just all distorted between the eyelets on the tines and the actual drive axle. So grade 8 shoulder bolts, little extra washers under here just because they're pretty small bolts and they really did want to bite into the aluminum, so I figured adding a little bit of extra washers, or a washer instead of none, this helps offset the load and makes that a little bit more reliable and robust. So anyway, that'll be my view. I have really hard soil in the areas that I was going to try to... God, that camera was freaking out there. Or the focus was. This was jittering around on my screen. Anyway, just nothing that this thing was going to even have a chance at. I really need like a spade on a rotary hammer versus something to till up soil. So I'll eventually do an update video where we just see how it runs. I mean, it'll run fine. These things kind of bounce around on the dirt until they kind of dig themselves in a ditch, and then the gearbox bottoms out, so you kind of go back and forth and offset it a little bit because it'll always, you know, high center on the gearbox, so you kind of have to offset. And you can dig pretty deep. You can dig, they claim 4 inches, that would be like average, but if you go back and forth and offset, I mean, there's about 8 inches of clearance from the bottom of the tines to this. And to tell you the truth, tines come pretty flush to this surface, so you could technically just go back and forth and trench really deep if you wanted to. So that's the deal with these. The whole point of these electric tools isn't to replace the really nice gas ones. It's for their convenience when you are near the house and you just want to till up an area of the garden where the pumpkin patch was or whatever. It's just a lot easier to plug something in and go at it. I'm just strange because I like to take things that are more budget conscious and then do what I can to improve them, to make them higher quality. And it's kind of fun to go through something like this and really improve it and actually have a lot more confidence in this now. Much better fasteners and the improvements to the motor. Ought to be a halfway decent little tiller, and it doesn't have like the double reduction. Some of them that do have the double reductions do have their advantages, but this doesn't have the extra gearbox or belts that can give you trouble. It's just a simple direct drive tiller. Anyway, appreciate Vevor sending this to me, and we'll see y'all next time.